Hey, this is Mr. Holly, and we are going to do the problem set for lesson 2. I'm going to take you through some of the questions here. Question number 1, David and Victoria are playing the integer card game. David drew 3 cards, -6, 12, -4. We need to remember that all 3 of these are integers, and they all communicate 2 things. They communicate direction and distance. So I need to answer, what is the sum of the cards in his hand? I'm going to model that by using vectors. The first vector to represent -6, well, -6 would have a distance of 6. It is negative, so it would have a direction to the left. Always starting at 0. Next, I have the integer 12. So I could begin at -6, because I need to begin at the end of my previous vector. My distance is 12. It is positive, so I'm going to the right. Let's put a little small arrow there. One thing that's helpful, a strategy that we'll continue to look at, is if I decompose this vector, like I know that this is a vector of 12, but I can think about it as 6 and 6, knowing that if I'm at -6, it would take 6 to return to 0. Here you have additive inverses, and then I have a remaining 6 left, so I'm going to be at 6. Now I have one more vector. It's at -4, or it is modeling the integer -4, which means I'm going to go 4 spaces, has a distance of 4, and it is to the left. If I return to the left 4 spaces, I would end up at 2. All right, number 2. Same question. Here are the cards, 2, 8, and -11. Then we're going to get an additional 7. So let's model the total on the number line. I'm going to go a little faster. 2, that is a distance of 2, and it's to the right. 8, it is a distance of 8, and it is to the right. -11. It is a distance of 11, it is to the left. I'm at 10, so I know I should go back 10 spaces to get to 0, and then an additional 1 space. And that would be -11. Now I'm at -1. I can go to the right 7 spaces. I know that's 1 and then an additional 6 spaces, so I should be at 6 on the number line. If decomposing these vectors seems confusing to you, don't worry about it. That's not something you need to focus on. It just really helps me to think about, how do I get back to 0, and then how many more spaces do I need to go? What cards would you need to get your score back to 0? So now I'm at 6, so I need to answer what card or cards would I use to get back to 0. Well, the additive inverse of 6 would be -6. So I could have any combination of cards that gave me a sum of -6. -1, -5, -2, -4, -3, -3, -6. I could even have some combination of like 4 and -10. Just any combination of cards that would be, that would be -4 and +10. Any combination of cards, well, I've really made a mistake on this one. I'm going to continue on with the video. No, I have not made a mistake. I apologize. I need the value to be -6. These cards would be -6. These cards would be -6. And I was originally correct over here. You would need 4 and -10 to make -6. Sorry for any confusion. Alright, let's continue. If a player gains 40 yards on a play, but on the next play he loses 10 yards, what would his total yards be if he ran for another 60 yards? Okay, so 40 communicates a vector of a distance of 40 and to the right. I'm going to use units of 10 on this graph, because that will get me up to 100 and I believe my sum is going to be less than 100. Okay, 40 to the right. Next, he loses 10 yards, so he has to go 10 to the left. It would be modeled with the integer -10. And then finally, he gains 60 yards, so that would be 60 to the right. That gets him to 90 as an integer, or excuse me, that is a vector of 60 and to the right. All right. Let's quickly look at number 4, and we're just going to do it on some number lines. Okay. First question, -2 plus 9. So I'm going to start at 0. 2 to the left, 9 to the right. Answer is 7. I will need to complete B on the back side because this one is going to go above 10 or -10. I'm going to go 8 to the left. That's -8. And then I'm going to go another 8 to the left. And that is -16 is my sum here. -16 and 7. Okay. Go back to these number lines. I have 3 vectors on this one. -4, so 4 to the left. -6, 6 to the left. And then 10 to the right. And that gets me back to 0, and the answer for C is going to be 0. All right. We're going to need to use our number lines that range from -20 to 20 on question D. And question D asks us to add 5, 7, and -11. So let's go 5 to the right, an additional 7 to the right, and then we need to go 11 to the left. Wow, that's really curved, I'm sorry. -11, this is 7, and we end up back at 1. Let's erase this. This should not, kind of took a big curve on me there. Okay. The answer is 1. All right. Question number 5 asks us to assign a value for point Z. So we are going to pick any value. Z is just going to be any integer. So I'm going to pick 3 as point Z, 3, and it asks us to place A, B, C, and D if Z has a value of 3. So because Z is an integer, I'm going to include it in my models, okay? So point A is 3 plus 5. Z plus 5, so it's going to be 3 plus 5. So we'll do point A right here, all right? If Z is worth 3, that's going to be 3 plus 5. And that would give me 8. So I'm going to come over here. Let's put point A at 8. That's going to be point A. B. It says Z plus -3. So Z is a vector of 3. And then we are adding -3. Wow, that's familiar. 3 plus -3. What vocabulary terms would apply to that? How about additive inverse, opposites? These are creating 0 here. So we're back to 0. Okay. So I'm going to put point B at 0. All right, now let's do point C. We're going to do it in order. It says -4 plus -2 plus Z, and remember we assigned Z the value of 3, so I'm going to go 3 to the right, and that puts me at -3. So at -3, I'm going to call that point C. Now, point D is negative 3 plus Z plus 1. So let's do that. D is going to be negative 3. So start at 0. Go negative 3. The next integer is Z. And remember, we are assigning a value of 3 to Z. And then we are also going to add 1. Now, obviously, if you assigned a different value to Z, your points are going to be at a different location. What is true is that they should all be the same relative to one another. C should be all the way to the left. B should be 3 spaces to the right of C. D should be 4 spaces to the right of C. And A should be another 7 spaces past D. So wherever you put Z, these letters, these points, should still have the same relative location to one another, even though their values would be different. It's all about what you chose as the value of Z. Okay, number 6. I'm not going to actually write a story problem here, but we can look at this and just kind of think through it. This is a vector of positive 9, this is a vector of negative 9, and this is a vector of 5. You could write a story about the football game. The football player ran for 9 yards. On the next play, the football player lost 9 yards. On the third play, the football player gained 5 yards. In all, he gained a total of 5 yards. You could do a problem about money. I earned $9 doing chores around the house. I spent those $9 at Taco Bell and got food. I was left with no money. Then I earned another $5. So now I have a total of $5. All right. We're going to do number 7, and we're going to skip number 8. If I look at number 7, it asks, do the arrows represent the equation 4 plus negative 7 plus 5 equals 2? Now, this equation is correct. We're going to start with that. It's correct. 4 plus negative 7 plus 5 does equal 2. Now, let's look at the model, and I want to ask, did they model it correctly? Because, guys, this will be a question on your assessments. You will be asked, are these models correctly modeling the addition of integers? You will have to be able to critique the models. So let's start here. My first integer is 4. I should start at 0 and go 4 to the right. Did I do that? Yes, that was correct. My next integer is negative 7. It should be 7 units to the left, but it should start at the end of my first vector. Does this vector begin at the end of this vector? And the answer to that question is obviously no, it does not. So this vector should actually start right here, and it should go 7 spaces to the left. There's 4, and then 3 more, and it would end at negative 3. Now, after you add 5 to negative 3, you would get 2. So the placement of this vector is incorrect. The placement of this vector would be correct were this vector correct. So we really just need to shift this vector and make sure that the vector begins at the end of the previous vector. That's what we need to do every time. Okay? And now the model is correct. If we get rid of this, now we have a correct model. And the sum is 2, and we're all good there. So, all right, guys, I hope you're able to have some success with this. Please reach out to your teachers for help if you feel like you were not able to be successful. All right, thank you.